having an opportunity to do this in a new generation of space exploration in which I can say that I'm honorably a part of.
You know, you come every day to the VAB and you see the rocket and you can't believe what we have accomplished.
People throughout history have always explored, and you never know what you're going to learn.
Exploration is not always about the destination, but it's the path that you travel, the things you learn along the way.
And the things we're going to learn are going to be incredible. We can't even begin to understand what those are today.
Our workforce has been a relentless spirit. We imagine, we build, we never stop pushing the envelope of what is possible.
NASA is preparing for a journey back to the moon, and after that, we're setting our sights on Mars. To get there, we need tons of rocket power coming from our Space Launch System.
When it comes to how much power this thing can push out, this thing is massive.
It's going to be mesmerizing to stand next to this massive vehicle. The immensity of it, knowing that this thing is going to be propelling a rocket into space and around the moon.
Hang on, it's probably best to start back at the beginning. It all started in Promontory, Utah, where Northrop Grumman manufactured each of the segments that make up the rocket's boosters. After a 10-day cross-country journey, the booster segments were delivered to Kennedy Space Center's Rotation, Processing, and Surge Facility, or RPSF. If this all sounds familiar, that's because it's the same facility that was used to process shuttle booster segments, which all came from Utah. Then they're ready to go to the iconic Vehicle Assembly Building, or VAB, where the rest of the motor segments are assembled and stacked on top of the mobile launcher.
So the one thing about this vehicle, of course, it's produced all across the country. Components all come here. They may be built around the country, but they all come together right here in the Vehicle Assembly Building.
Our SLS rocket will generate 8.8 million pounds of thrust to break through Earth's gravitational pull. That's more power than the Space Shuttle and the Saturn V rocket used. Teams with NASA's Exploration Ground Systems are responsible for assembling the boosters that will house the majority of that power. The twin solid rocket boosters, made up of 10 total motor segments, will stand nearly 17 stories when fully stacked. First, teams will inspect and prep the hardware. Next, they're ready to start stacking the segments, a process that takes time, patience, and a steady hand.
Once we have everything done in High Bay 4, we pick up the segment with the 325 crane, pick it up over the 16th floor crossover to where you see it now, and we begin stacking the segments. Each segment, we lift over the 16th floor crossover and stack it. Once we stack it, we put it on top of the segment below, and we put about 177 pins all the way around the whole thing to attach each segment.
And the pressure to perform the operation flawlessly can test the team's nerves.
There's a tremendous responsibility involved with processing flight hardware like this. It's nerve-wracking at times, but it's exciting. There's zero appetite for risk in a program like this.
We have a bunch of shuttle guys that are here to show us along the way. You know, if we get stuck, they're there to guide us. At the beginning of the stacking, it was very nerve-wracking. You know, with each segment that we stacked, a little bit of the nerve comes off. By the third or fourth one, it's easy peasy. You know, we're pushing through, all the jitters are gone, and we're just excited to get finished with it.
With all 10 booster segments now fully stacked on the mobile launcher, there's just one final piece of the puzzle to round out the power needed to get SLS off the ground and send it to space. core stage. After a 900-mile journey aboard NASA's Pegasus barge, the SLS core stage, the largest rocket stage NASA has ever built, has made it to Kennedy Space Center.
Today is a huge day. This is the last piece of big hardware that we need for Artemis 1 processing. And we've just been waiting a long time for this part of the vehicle to arrive so that we can get going on the next steps of our stacking operations.
Standing an impressive 212 feet tall and weighing a whopping 188,000 pounds, the core stage came all the way from Stennis Space Center in Mississippi. The core stage went through round after round of rigorous testing, including what's called its Green Run series, truly putting its performance to the test. The series involved 8 rounds that looked at systems individually before culminating in pure power.